Okay, so this is a continuation from yesterday. So we are still doing Unit 6, Day 2. We are talking about writing formulas and writing names or naming ionic compounds. Your quiz is going to be online. So what I'm going to do is I'm going to put the quiz online tonight. I will open it for tomorrow, and it will be open until Sunday night. So you have Thursday, Friday, Saturday, and Sunday. Anytime over those 4 days, you can take it, but you will take it online. We will not take it in class. So everyone will take the quiz online. All right? If you have any issues with that, please let me know, and I can figure something else out. But I want everyone to take it online so we can get it done and get it out of the way, and then we can still continue to do things in class so we don't get behind. Okay? So your quiz will be online starting tomorrow. You have until Sunday night at midnight to take it. Once you get into the quiz, do not try to exit it, because it will kick you out and you will not be able to get back in, and you won't be able to do it. And then whatever grade you get, that's your grade. Okay? So give yourself a full opportunity to take it in one sitting. Okay? Make sure you have time to do it when you go to do the test or quiz. Sorry, quiz. Right? If you got a message sent to your parent last night about you either being in my D or F list, then that means that I have no grades for you, or if I do, I have 1, because you have not submitted anything to me. So if I need to grade your notebook, please leave it with me at the end of the class whenever it is ready to be graded, as soon as possible. I would love to do it before you leave for Thanksgiving. Yes, Louie.
I don't have any other work.
Everything is on Canvas. Literally everything is on Canvas. Everything is on Canvas. So you need to go home. Louie, listen. You need to go home, go onto Canvas. Under modules, everything is listed. And if you click on everything one at a time, it will give you the worksheet to print out and work on. Some of them, I have the key on there for you already. A lot of it has YouTube videos, like I'm doing right now, where you can watch the actual class lecture. Everything is on Canvas. If you go into Canvas and you go into modules, I have everything in modules. Everything.
I know.
Everything. I will make sure to cut this out of this video, because Lord have mercy. I shall say it again. Everything is on Canvas. If you are ever quarantined, everything is on Canvas under modules. Whew. Okay. So. Okay.
Because now I can't watch stuff. No, I gotta do
Okay. So we need to finish our notes on naming and writing formulas for ionic compounds. So quick review from yesterday. Yesterday we did the basic thing. So your first step with writing ionic compounds, I will give you your elements. Your first step is to find the oxidation number. Once you find your oxidation number, you write it above each of the elements as an exponent or a superscript, whatever you want to call it. Once you find your oxidation number, you grab your oxidation numbers, you crisscross and you bring them down, and you write them as subscripts. And then your last step is to simplify it. So what do I mean by simplify? I mean get rid of your charges. So you should not have negatives or positives. And then get rid of your number 1. We do not write the number 1, because if we're writing the element's symbol, it is redundant to write the number 1. If we're writing the symbol, that means we have at least one of those things. So we don't have to write the number 1. So get rid of your charges. Get rid of the number 1 if you have it in there. And then whatever you're left with, that is what you write. So if you have BA and then CL, your +2 crisscrossed and came down after your CL. Your -1 crisscrossed came down in between your BA and your CL. So then you would have BA -1, CL +2. I don't write my charges, and I don't write my number 1s. So then I would simplify that into BaCl2. if you had Ba2Cl2, you could further simplify that into BaCl. So if you have a 2 and a 2, you can simplify that to 1 and 1. If it's 2 and 4, you can simplify that to 1 and 2. So you need to make sure that at the end of the day, your formula is in the simplest form. Okay, so your numbers are the smallest numbers they can be. You don't have any number ones and you don't have any charges. So that's what we did yesterday. So now, how do we name ionic compounds? So let's say I give you an ionic compound. So I give you BaCl2, and I want you to name that compound. Well, when you name ionic compounds, it's very easy. All you have to do is write the name of the metal. So your metal goes first. Write the name of your nonmetal. Your nonmetal goes second. Take the ending off of the nonmetal, replace it with IDE. That's it. So if you have an ionic compound between sodium and chlorine, that compound's name is sodium chloride. Okay, so I write the name of my metal first, so I write sodium, and then I leave a space, and then I write the name of my nonmetal, which in this case is chlorine. I take off the ending of INE, and I replace it with IDE. So for zinc, I write my name of zinc, I leave a space, and then I write my second element, which is iodine, but I take off the INE ending, and I replace it with IDE, so that's zinc iodide. And then Al2O3, the first Al, that is aluminum, so I would write aluminum, leave a space, and then this is oxygen. For oxygen, you have to take a little bit more off. Unfortunately, there's no rule as to know what is the ending of your element name. So for oxygen, you have to take off the YGEN and replace it with IDE, which is oxide. So this one, you just have to remember that if you have oxygen as your nonmetal, your ending is going to be oxide. Right? So write the name of your metal first, write the name of your nonmetal second, and then write your ending of your nonmetal as IDE. Okay. Why? Never mind. Okay.
He's not going to be here tomorrow, don't worry.
Okay, so do these in your notebook. There you go. Do those in your notebook. So finish writing the formula names for these three, and then give me the entire name for this one. So write the name of your metal first, the first three, that is done for you, and then write the name of your non-metal second, and then change the ending to IDE. Yes, ma'am.
This chart. How do you find the oxidation numbers?
So your oxidation numbers, you have to know what column it's in. So barium, for this one, barium is in column 2. So it has 2 valence electrons. It wants to, your oxidation number is whatever it's going to do in order to get 8. So barium has 2 valence electrons, it wants 8. So it can either gain 6 or it can lose 2. But you want to know which one is the easiest one. It's easier to lose 2 than it is to gain 6. So barium is going to have 2 because it's losing 2 electrons. When you lose electrons, you get more positive. So you can think of it that way, or what you can do is, and I'll come show you. What you can do is you can memorize. Column 1 is always going to be plus 1. Column 2 is always going to be plus 2. Please stop doing that. So this is plus 1. This is plus 2. Happy if you're changing elements, those don't count. This is always going to be plus 3. 4 is the hard one, or you can do it can do a gain 4, or it can lose. So I usually won't This will not have an oxidation number to any of the gases, and they're not reactive. Correct, they're not reactive. So you can do that. Okay. And then you just have to look and see, okay, what column am I in? Okay, and then I know that this is column is gonna be -3. Yes. So that's how you can do that. All right, so for Na3N, that is sodium what? Nitride. KBr is potassium bromide. Al2O3 is aluminum oxide. And then MgS is
Magnesium sulfide.
magnesium sulfide. Very good. Oops, sorry. Here. Okay. So you write the name of your metal first. You write the name of your non-metal second. And then the ending of your non-metal is going to be IDE. Some of them will be easy because you just take off the I and E and replace it with IDE. But some of them may not be that easy. So nitride is another one because it's nitrogen. So how do you know how much to take off? There's not really a rule that I can tell you. It's just nitride. You're just gonna have to remember it. Sorry. So then you would take off IUM and replace it with IDE. What element is that?
All of them.
There's so many of them.
But if it's a metal,
If it's a metal,
you don't do that.
Oh,
If it's the metal, you leave it alone. So look, sodium,
Yeah.
you just leave it sodium. You don't have to change it. It's only the non-metal that you're changing. Okay?
And the non-metals on the right side of the staircase?
Yes. So this is on the left-hand side of the staircase, so that goes first. This is on the right of the staircase, so that goes second. And then the only one you're changing is the ending of the non-metal, the ending of the second one. Good job. Okay, so now we need to know how to write formulas and names of compounds that contain transition metals. Because remember, our transition metals don't follow our rules for oxidation numbers. So I have to give you, basically, I have to give you the oxidation number of that transition element if you have one. How I'm going to do that is I'm going to be using Roman numeral numbers. So you do need to know how to write Roman numeral numbers. I think 6.
Is that BI?
I think, yeah, 6 is BI. I think that's the highest. I don't think you'll use 6. I think you'll go up to 5, but you may need 6. But no more than 6.
Is it like L50?
Oh, I don't know. Anyway, so for this example, your copper, guys. So copper can have an oxidation number of +1 or +2. So then your Roman numeral number will either be 1 or 2, depending on which one you're dealing with. So if you have the oxidation number of +1, if you have copper 1, you have to say, I have copper 1. So you do have to write the Roman numeral number 1 inside parentheses for this oxidation number of copper. So usually I say you don't have to write the number 1s. For this you do. You have to tell me that it is copper 1. It has an oxidation number of +1. Okay? And then for iron, iron can either be +2 or +3. So you'll either have the Roman numeral of 2 or you'll have the Roman numeral of 3. So for writing compounds and naming ionic compounds that have transition elements, you're either going to be given a Roman numeral number and you have to change that into the oxidation number, or you will be given the oxidation number and have to turn it into a Roman numeral number. So, here. So real quick, do these. So choose the best formula, or what is the correct formula for each of those pairings. probably did that line. This is the line. So yeah, just take pictures of everything, submit them online, and I can grade it that way.
And I also print out the periodic tables for page 30.
And then once you get that colored and get the arrows on there, send a picture of it and submit that with the notebook check assignment, and then I can grade it all. All right. So sodium and oxygen. Sodium has an oxidation number of +1, and oxygen has an oxidation number of -2. So what is the compound going to be? What's the formula going to be?
Na2, or 2.
So we think number 2.
Yeah.
Yeah.
All right. The formula for aluminum and chlorine. What would aluminum and chlorine be?
Number 3.
Number 3. Any objections to number 3? Okay. What about the formula between Fe3 plus and O2? What would be that formula? 3. Any objections to 2, 3, and 3? Very good. Yes. So those are your formulas. So again, you find your oxidation numbers. Guys, listen. You find your oxidation numbers. You crisscross, you bring them down. You do not write the number 1. You do not write your charges. And then you simplify. If you have similar numbers, so you have 2 and 2, that can simplify. 3 and 3, simplify. 2 and 4 can simplify. Stuff like that. Okay? So, back to transition elements. So again, my oxidation number is going to be the same as my Roman numeral number, or my Roman numeral number is going to be the same as my oxidation number. These are all transition metals, so because they are all metals, they are all going to have positive oxidation numbers, because our metals always form positive ions. So these will always be positive numbers, okay? And then when you write your Roman numeral number, you just worry about the number. We do not write the charges. So for a bond between iron and chloride, it would be iron 3 chloride because, so over here, I showed you how to take your elements and turn them into a compound. So how do you turn your compound back into elements? You have to do the reverse. So you have to come down here, grab your numbers, crisscross, and bring them back up. So you do the opposite, all right? So this number here, this is an imaginary 1. Remember, we don't write our number 1s in our formula. So if there is no number there, you automatically assume that it is a number 1. So this number 1 is going to be crisscrossed and brought up to the chlorine, and this 3 is going to be crisscrossed and brought up to the iron. So that means that iron is going to have the 3 and chlorine is going to have the 1. Now iron is a metal, so it is always going to be positive. Chlorine is a non-metal, so it will always be negative. So this is your oxidation number for your iron, and that tells you what Roman numeral number to use. So crisscross, bring them up. Find out what the oxidation number is for the metal, for the transition metal. That number is your Roman numeral number. So again, if you do not see a number for this one, there are no numbers. So what do we automatically assume both of those numbers are? 1. So we bring up, crisscross and bring them up. So Cu will be +1 and Cl will be -1. So then the +1 tells us that we are dealing with copper 1 chloride. Again, grab your numbers on the bottom, crisscross, bring them up. So that means that your 10 is going to have an oxidation number of 4 or +4, and your fluorine is going to have an oxidation of -1. So then the 4 tells you that you're dealing with 10,4 fluoride. Lead 2, so this 2 over here, crisscross, bring that up. There is an imaginary number 1 there, So you crisscross and bring that up. So lead is going to have the +2 oxidation number, and chlorine is going to have the -1 oxidation number. So then your +2 on your lead tells you that you're dealing with lead 2 chloride. And then last, you have this 2 and this 3. Crisscross and bring them up. So that tells you that your Fe will have a +3 charge, and your sulfur will have a -2 charge. The metals are always positive, the nonmetals are always negative. Your Roman numeral number is the oxidation number for the metal. You don't care about the oxidation number for the nonmetal, for transition elements. You're just looking at the transition metal. So then this would be iron 3 sulfide. Does that make sense? So if I give you the elements, or if I give you the name of the formula and want you to write the formula, hold on. If I give you the name of the compound and want you to write the formula, you crisscross and bring them down. If I give you the formula and want you to write the name, you crisscross and bring them up. Yes, ma'am.
What's the things in the parentheses in the middle?
These?
No, in the, yeah, that.
These are your oxidation numbers for those transition elements based on what you did over here. So I just rewrote them here. Okay? Alright, so now I want you to try these. So the first two, all I want you to do is figure out what Roman numeral number should go here. And then these 3, I want you to write out the entire name. Yes, ma'am. Yes. So take a few minutes to work on these. So I'm giving you the formula and you have to write the name. So grab your numbers on the bottom, crisscross and bring them up. And then that is what your oxidation number is. And then your oxidation number for the metal is what the Roman numeral number will be. Okay. So for your first one, iron bromide, what Roman numeral number will you put in parentheses for iron bromide? 2. Because this 2 is going to crisscross and go up to the Fe. So then Fe would have an oxidation number of +2. There is no number here, which means there is an imaginary what? 1. So that imaginary 1 gets crisscrossed and brought up to the Br. So those are your 2 oxidation numbers. The only one that you are concerned with is the one for the metal, for the iron. because that oxidation number tells you what Roman numeral to put here. So for this one, Cu2O, what Roman number will you put for this copper? Or what is the oxidation number for this copper? 1, yes. So the 2 is going to be associated with the oxygen, and this invisible one here will be associated with the copper. So that's copper plus 1. Yes, ma'am.
How do you know which one, like in parentheses for the first one, you would go with Fg? How do you know, like, which one to focus on?
You are going to focus on the metal.
Okay.
So the first one, the iron, the copper, whatever the first one is, that is your metal. That's the one that could have multiple oxidation numbers. So that's the one that you have to say, what is its oxidation number with a Roman numeral number? Okay. All right. So what about SnCl4? What is Sn? 10. So 10. And then for this pairing, what would the oxidation number be for 10? 4 or IV. And then what is the second part of this name? Chloride. Very good. And then Fe2O3. So what is the first part? What's the metal?
Iron.
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 And then this 2 is going to crisscross and go up to the oxygen. So the 3 is going to crisscross and go up to the iron. So what Roman numeral are you going to write? I, or 3, yes, whichever. And then what's the second part of this name? Oxide. And then what is Cu? Copper. What is the oxidation number for this copper in this 1? And then what's the second part? Sulfide. Very good, guys. Yes, ma'am.
So for the second to last one, I put Roman number 2 at the end. Is that not right?
No, because the Roman numeral number is associated with the metal. So if you put it behind the non-metal, then you're telling me what the non-metal's oxidation number is.
3 oxide 2.
You only are concerned with the metal.
Okay.
So yes, oxygen does have an oxidation number of 2, -2, but it doesn't matter, because it will always be that way. This one is the one that's changing. So this is the one where you have to say, for this example, it's 3. In another example, it could be 2. But for this one, it's 3. Okay? Any questions about transition metals? All right. So, write the formulas, or tell me which of these formulas is the correct one for those 3. The correct name for the formula. So tell me which one is the correct name for the formula.
Don't say that one.
Oh, which one?
I actually did this one. This is like the first time I've really talked about this. Yes.
Oh, tetra is used for covalent bonds, so we'll talk about that when we talk about covalent bonds. So it's not that one.
Yeah, basically, the number only goes to the middle, not the bottom.
I put it on that one. I'm looking at this one. I know, Starry Night.
So I can't wait till the senior needs like.
Actually, let's do this, for you, I'm really cool. Everyone.
You need to leave up the
Stinky green shoe. Alright, that's really mean, But if I get green juice. What?
What's your GPA?
My in-laws. I'm married.
All right,
That's a good deal, laugh.
guys.
I did not say.
All right. So for CaO, what is the correct name for CaO?
Calcium two oxide.
Calcium 2.
Oh, calcium one oxide, sorry, I was thinking of
It's
number.
not even calcium 1.
Which one do we think it is?
Transition metal.
You think it's number 1?
Yeah, it's not a transition.
Okay, what about B? What do you think B is?
Three.
Three is three.
We
Three.
won't agree on that one.
What about C?
Two.
2? Anyone have any other? Yes?
I got a different answer for
Okay.
Yeah, it's.
What do you think A is?
No, it's not two.
Two.
2?
It's not a transition.
I thought it was
It's not a transition metal.
Let's just do the answer.
So,
The transition metal is you put the number in the box.
Oh, no, never mind, I retract my statement.
But then,
sorry.
It's not a transition.
So yes, calcium is in column 2. So is calcium a transition element? No. So is it going to have different oxidation numbers for different compounds? No, it will always have an oxidation number of 2. So do you need a Roman numeral number for calcium? No. So that is why it's number 1. That's why it's just calcium oxide. If it's not a transition element, you do not need Roman numeral numbers. Your Roman numeral numbers are only for transition elements that can have multiple oxidation numbers, and so you have to tell me what oxidation number it is. Does that make sense? Okay, well, good job on the other 2. All right, so what I have for you right now is I have number 3.
oh, you're done.
No, that was finishing up number 2.
Wow.
Okay, so I have number 3 for you. It is a packet, so there are 2 pages front and back. What we are going to do is I'm going to give this to you now. You can start on it now. We will work on it together tomorrow. So that means Tanner, you got this tomorrow, right? Yes.
Tanner, I don't got to look for you.
All right. Oh, one more thing. Sorry. Hold on. So this packet, I have not showed you, guys, listen. I have not showed you everything that you need to know to complete this packet. So some of these are not going to make sense. Skip them. I will show you more things tomorrow, and I will show you more things Friday. So we will work on them gradually, okay? So do as much as you can. We'll work on it tomorrow. We'll work on it Friday. Do your quiz at home online. The quiz is only from Unit 6, Day 1. So only that PowerPoint is going to be your quiz, okay? Okay.
Yeah, like all your favorite Why did you do that?
Okay, so let me show you how to do this real quick. Let me do a couple of these for you so you at least know or have an idea of what to do. Okay, so I am giving you, listen, I am giving you 4 pages of ionic names that you have to turn into formulas. So you're going to do it step by step, because the more times you do it, the better you'll be at doing it after you do it a bunch of times. All right, anyway. So for sodium chloride, you're going to tell me what is the cation and what is the anion. So for sodium chloride, what is the cation? What's the metal ion? Because our metal ions make cations. So what is your metal?
Sodium.
Sodium. So our metals are always going to make cations. What is the oxidation number for sodium? +1, because it is in column 1. Okay, what is our anion? What is the ion that's going to be negative? Chlorine. And then what is the oxidation number for chlorine? -1. So that is your cation and that is your anion. Your metal is the cation, your nonmetal is the anion. So the first name is the cation, the second name is the anion. For this column, you are going to show me this part, the crisscross and the bringing it down. So you write it as exponents first, So Na plus 1, and then Cl minus 1. So your oxidation numbers are written as exponents. And then you circle your exponents. You circle your oxidation numbers, you crisscross and bring them down. So that is Na minus 1 and Cl plus 1. And then you have to simplify it. So that means that you get rid of your charges, you get rid of the number ones, and then you simplify your numbers if you can. What it means by reduce. Can you reduce your subscripts into smaller numbers?
Seniors?
Can you reduce 1 and 1
Yes.
No. No?
to still be numbers?
Oh,
You can't be 0 and 0 because then you have nothing. So you cannot reduce this. If you had a 2 and a 2, could you reduce that?
Yeah.
Yes. If you had a 4 and a 4, could you reduce that? Yes, that's what it means by reduce. Can you make these numbers smaller? That's the only thing it means by reducing.
Like, never mind.
So then you're going to come over here and you're going to turn this into your final form. So you do Na and then Cl because you don't write your charges and you don't write your number ones. For calcium bromide, for this one, what is your cation? What is your cation for calcium bromide?
Ca. Right, is that what calcium is?
Yes.
Is that?
Someone, can I have more people saying what a cation is for this one? What is the cation? Calcium. So yes, it is Ca. What is your oxidation number for calcium? Plus 2? Yes, plus 2. What is your anion? Bromine. So that's Br. What is the oxidation number for bromine? Minus 1. So then you come over here and you write Ca plus 2 as an exponent, and then Br minus 1 as an exponent. You grab your oxidation numbers, you crisscross and you bring them down. So that is Ca minus 1, Br plus 2. And then I need to simplify it, and then I need to reduce it. So I get rid of my charges. I don't write the number 1. Anything left over, I do write.
Juniors?
So it's CaBr2. Can I reduce 1 and 2? Can I make a 1 and a 2 smaller? Think of a fraction. Can I make 1/2 smaller without? So the common denominator. You have 1 over 2.
Can you change it to CA and then like erase the 1 and then BR1? Is that wrong?
It's a common denominator.
Okay.
So can you reduce 1 and 2? No, you cannot reduce 1 and 2. It's a common denominator. I don't know how else to, I'm sorry. All right, we'll work on it more tomorrow.